Hello everybody, Mr. Gubino here. We're going to talk about inscribed angles. Today is Wednesday, May 13th, 2020. And we will be going into more of the angles that are formed within a circle. So we're going to talk about inscribed angles here. So hopefully you have your notes printed out. If you don't, go ahead and print them out, or you can just follow along on your iPad if you are able to. So this is what the notes will look like, inscribed angles. And if you notice, the inscribed angle is here. So we are looking for an inscribed angle. So the definition of an inscribed angle is an angle whose vertex is a point on the circle. The vertex is on the circle with sides that are secants or chords. Remember that a chord is part of a secant. It goes through the chord. All right, so a chord, here we have two chords. We have CD, or part of that secant, and we have CB, which is another either chord or secant. That angle is an inscribed angle. Inscribed angle. Angle DCB. C is your vertex. D and B are points that are on that circle. Okay, so this is the vertex, of course, and these are two other points on the circle. And if you notice, C is also in a circle. So we're looking for the measure of this angle. Well, how are we going to find the measure of that angle? So what we're going to do is we're going to look at the central angle. So if we look at the central angle, which is DAB, so we have a circle here, and we know that if we have this arc right here, it is going to be the same measurement as this angle. Okay, so just if we call this, let's say, 140 degrees. Okay, so angle DAB is a central angle. Arc DB is a minor arc. If the measure of angle DAB is equal to 140 degrees, then that is also the measurement of the minor arc, DB. So this would be 140 degrees. Now, what are the other parts? So what would be angle DCB? Well, we're going to talk about this word down here, intercepted arc. So let me zoom out just a little bit. An intercepted arc is the arc formed by intersection of the sides of an inscribed angle. It could be of a central angle. Oops, what happened there? Technical difficulties. Hold on for 1 second. Sorry about that. Little technical difficulty. It closed up on me. Here we go again. So the intercepted arc is the arc formed by the intersection of the sides of an inscribed angle and the circle. It is the interior of the angle. It is the portion of the circle that is on the interior. So DB right here would be your intercepted arc. All right. Now, if that is your intercepted arc, if it is a central angle, it's going to be the same. Here's the rule for the intercepted arc. The measure of the inscribed angle, DAB. If an angle is inscribed in a circle, so there's my hypothesis, then here's my conclusion. Its measure, so the angle inscribed in a circle, its measure, angle DCB, is, there's your equal sign, half, well, the measure of the intercepted arc. The measure of half the intercepted arc. So the measure of angle DCB is half the intercepted arc. Well, if I said that this was 140 degrees, because my central angle is 140 degrees, then the measure of angle DCB is going to be 1/2 of 140 degrees. So the measure of angle DCB is going to be 70 degrees. So this angle right here is 70 degrees. It's going to be half of what that intercepted arc is. Okay, so if that was true, that is 140, that arc intercepted from the central angle is going to be also 140, which makes, if I look at this, kind of the ice cream cone, it's going to be half of that intercepted arc measurement. So if I give you that this was 70, you're going to double it to get the 140. Okay, so another way to write that, so this would be your main one. 2 times the measure of angle DCB is equal to the measure of arc AB. And that's basically doubling the inscribed angle equaling to the intercepted arc. Okay, so if it's a central angle, it's going to be equal. If it's half, it's going to be half that intercepted arc. Okay. All right, let's take a look at the next page. We're going to go over a couple examples, so it's okay. We'll look at it. If 2 inscribed angles of the circle intercept the same arc, then the arcs are congruent and the angles are congruent. So I'm going to color code this. Let's go with blue. So let's take a look at the intercepted arc of DB. Okay. So the intercepted arc of DB, let's go red. I'm sorry. So this arc right here, I have 2 inscribed angles that deal with DB. One of them is this angle, DCB. The other one is DGA. So if they both hit that, then what happens is, let's say this was our 140 again. So if the measure of arc DB is 140 degrees, then the measure of angle DCB is half of that arc, DB, which is 1/2 of 140. So the measure of angle DCB is going to be 70 degrees. Well, if this blue angle hits at the same endpoints and intercepts the same arc, then the measure of angle DGB is also going to be 70 degrees because it's hitting at the same angle. No matter where I put that circle. If I wanted to have an angle way over here, let's say I had an angle way over here and it hits that arc, that angle is 70 degrees as well. Okay, so if I put my vertex here and I connect it here, that is going to be 70 degrees right at that vertex. Okay? All right, an inscribed polygon. A polygon whose vertices are points on the circle. We have inscribed a polygon before. We did that when we did, what was it? We drew a circle around the rectangle. Here, the 2 inscribed, so you're putting a polygon inside of a circle. If I circumscribe something, I'm talking about the circle that touches each of the vertices. Okay, so here I have a right triangle. If a right triangle is inscribed, so this is not, this would be your right angle right there. Angle K is a right angle. So triangle JKL JKI is a right angle. Measure of angle K is 90 degrees. Oh, let's think about this. Let's go back to what we learned previous. This right here is a diameter, right? And if that is a diameter, I'm going to zoom in on this. If that is a diameter, then this arc measures, it keeps cutting out on me. Hold on for 1 second. All right, I'm sorry about that. It keeps cutting out on me. I don't know what's going on. So we're going to power through. I'll look at it, see if it did it okay. So if JHI is that diameter, which is also a straight angle, so the measure of angle JHI is 180 degrees, then arc JI, semicircle, now also if you think about it, JKI is 180, so we're going to go here, I'm just going to put, let's put C, so JCI is 180 degrees, that's a semicircle. Okay, so if that's a semicircle, this angle is 180 degrees. Well, if you notice, right here, these are the sides of that right angle, and they hit this intercepted arc. And this is an inscribed angle. So if the measurement of angle K is a 90-degree angle, then the measure of angle K, which is 90, is going to be 1/2 the measure of arc JCI. Well, that is 1/2 of 180. Yep, that makes sense. Now what happens is, once we get those values, so if that's 180 degrees, let's just say that this would be 100 degrees. So 180 and 100 is 280, which would make this arc 80. Because if we have a circle, it's got to be 360, right? So when I look at that, if that's 100, if this part's 100, then this is going to be half of that, 50 degrees in there, right? And if this arc is 80, then this half arc is 40. And if you notice 40, 50, and 90 add up to be, that's right, 180 degrees. So therefore, when you're looking at this, you have a right triangle. The diameter, the hypotenuse, is going to be the diameter of that circle. So the diameter of the circle is the hypotenuse of a right angle that is inscribed on that picture. Pretty interesting. All right, so a quadrilateral can be inscribed in a circle if and only if. So this happens only when these things are true. Opposite angles are supplementary. Oh, opposite angles are supplementary. So angle K and angle L are supplementary. Oops. And likewise, angle J and angle I are supplementary. Okay. So that's only true in a couple of shapes. Opposite angles are supplementary. Let's think back to our quadrilaterals. We have a rectangle. And if we have a rectangle, we probably have a square because they're all 90 degrees, right? And then the only other one that has supplementary angles that are across from each other is the isosceles trapezoid. Not a kite, not a regular trapezoid, an isosceles trapezoid. Okay, and why? If I draw one just kind of here, and let's say this is 60, and this is 60, this is 120, this is 120, these two angles, so you will be able to draw a nice circle around those. I just did it. That is a circle. Don't question me. I'm kidding. I'm kidding. I'm kidding by far. Okay. So let's go through a couple examples. So you're going to have a delta math, but let's just go through a couple of these examples. I'm going to go over the first one. You try the next ones when we get there, and we'll go from there. So first one, find the measure of the inscribed angle or the intercepted arc. Just depends on which one you're asking for. So in this case, if I give you 72 degrees, I want to know this arc right there. And that arc is going to be, so this, the measure of the angle DEF is 1/2 the measure of arc DF. Alright, so I gave 72 degrees here, 1/2 the measure of arc DF. So I'm going to get rid of this by multiplying that by 2. So the measure of arc DF is 144 degrees. I gotcha. Alright, so I want you to pause the button, pause the video, and then come back and do number 2 and number 3, and I'll show you what I got. Okay, so you got the measure of angle JKL is equal to 1/2 the intercepted arc of JL. So that is 1/2 of 42, which is 21 degrees. So the measure of angle JKL is 21 degrees. If this angle is 112, then this is the intercepted arc. Measure of angle XYZ is 1/2 the measure of, in this case, it's a major arc, XWZ. So it's 1/2 of XWZ. And the measure of this angle is 112. So the measure of arc XWZ is double this to get rid of that, 224 degrees. Sorry about that. Moved it over. It's probably going to go out on me, but that's okay. We'll try it here. Okay. So here we have a right triangle. These are all right triangles. Notice the diameter. What's the measures of x and y? Well, x is 90 degrees, because that's 180 over here. If that's 52, then 52 from 90 is 38 degrees. Whoops. Sorry about that. So the intercepted arcs would be 180. This one would be 104. And if that's 38, that would be 76. And if I add 180, 76, and 104 together, I get 360 degrees. Okay. Here's my diameter, which is my radius. Therefore, x is 90. And y would be 10. Because you have a triangle there. So this arc over here would be 180. This arc right in there, if that angle is 10, this is going to be 20. And that is going to be double 80, 160. Pause that video, do number 6. Alright, y is 60. Y is not 60, Mr. Gumino. Y is 90. These two add up to be 90. So 3x equals 90. X equals 30. So x is 30, and 2x would be 60, which would make this 60 and would make this 120. Okay. All right, and then this number 7 goes through. It is a quadrilateral that is inscribed, which means that the two values have to be supplementary from across from each other. So these two have to be supplementary. So 180 minus 70 is going to be x. And these two are going to be supplementary, so 180 minus 113 is 67, which is going to be y. Pause the video and come back. Oh, sorry. I'm going to pause my video for 1 second. Unpaused. Here we oh, it's like magic. So the opposite angles should be supplementary. So both of those add up to be 180, 103, and 120. And likewise for 9. So if you need to pause that, go ahead and pause that. All right, so here is practice that goes along with it. That's the 4th page. I am going to put those answers up so that you can check those. I do believe that you have also a quiz on central angles and arcs, central angles and arcs, and also a delta math assignment that goes along with central angles. Okay? So that is tonight and goes until Sunday. I will also post probably tomorrow your scavenger hunts. Or actually today, later today. Today is Wednesday. I'm sorry. So I will probably post that too. All right. If there are any questions, shoot me an email. I will look through this video, see if there's anything. I might do a separate video on this page, but generally speaking, I'm just going to put up the answers and do a couple of things of work. I may give you a video on the answers, but we'll go from there. So check Delta Math. You will also probably be getting emails about Delta Math. And if someone gives me the code word because they've answered this, just put it in the, I don't know where we're going to put it. You're going to include this on your scavenger hunt. So one of the questions is going to be, what is the code word? And the code word is hold on for it. Let me see. The code word you're going to have to watch is scissors. Once again, the code word that you're going to put on your scavenger hunt is scissors. Just to make sure that you have been looking at this video and watching it. Hit the like button, subscribe. Also, code word. Scavenger hunt number 4, code word is scissors. All right? Because we need a haircut. Oops, sorry. Okay, so I will see each of you later today. That's right, we got our meetings today starting at 10:40 to 11, 11:10 to 11:30, and 11:40 to 12. Otherwise, I'm going to see you later. I know this is beginning of a week, so we'll get going on this. All right, have a good day.